This call is now being recorded.
Okay. So in the last lecture, we have covered the problems based on the type number 2, that is problems based on the kinetic energy. That means how the kinetic energy is useful to find out the stress and the elongation. So there is a basic difference between the type number 1 and the type number 2. So in the type number 1, what are the problems we have solved? All the problems are based on the gradually applied load, or it is subjected to the suddenly applied load. That means whatever the type of load is applied, whether it is gradually, so we are having the direct formula sigma is equal to P upon A. If the load is applied suddenly, then we are having the direct formula sigma is equal to 2P upon A. That means the condition is mentioned in the statement, and by using that particular condition, we can find out the stress by using the directly formula. But type number 2, in that, whether load is applied gradually or whether load is applied suddenly, that like that word, it is not mentioned in the statement. But in addition to that, the speed of that particular rod, or the speed of that particular lift, or the speed of that particular wagon, it is mentioned in the form of meter per second, or sometimes the velocity is mentioned in the meter per second. So immediately we can say that in that particular numerical, first of all, we have to calculate the kinetic energy, and then by using the equation total strain energy is equal to kinetic energy. So kinetic energy we can calculate by using the formula 1/2 mu square. So we can put the value of G in meter per second square, value of V in meter per second, and initially we'll calculate the kinetic energy in Newton meter per second, and again we'll multiply by 10 raised to 3 and we'll convert in Newton mm per second. Then that kinetic energy we have compared with the strain energy, that is kinetic energy is equal to sigma square upon 2E into volume, and by using that particular formula, initially we'll calculate the sigma and then we can calculate the deformation. So for the deformation calculation, the formula is same for all the three cases, that is deformation is equal to sigma L upon E. Okay, that numericals also we have discussed in the last lecture. Also we had some little bit introduction related to the type number 3, that is problems based on the impact load. So what is meant by the impact load? If any weight or if any movable load is strikes on any component, or if it is falling from certain height, then that load is called as a impact load. So initially there is no any contact between that particular component and the movable load. There is some certain distance, and that distance is called as a height. If the height is present in between that particular component and the movable load, then that height is represented by the capital H. Then we can say that that particular numericals we have to solve by using the concept type number 3 related to the impact load. And if the load is falling from certain height, and if I have to calculate the stress or the maximum stress, then we are having this particular formula, which formula sigma is equal to P upon A in square bracket 1 plus square root of 1 plus 2H upon delta L. This delta L means PL upon AE. So we are having the delta L PL upon AE. If I will reconvert it, 1 upon delta L means AE upon PL. The same formula I have written. So the same formula I have written in the form of PL upon AE. And then second formula also we are having, that is strain energy is equal to work done. So we are having the standard formula for the strain energy, sigma square upon 2E into volume, and work done means force into displacement. So how much amount of force is applied? The P amount of force is applied. How much amount of displacement is taking place? H plus delta L, because whatever the load is applied, that load is falling from certain height. Therefore this height is considered as a capital H plus delta L. If that load is falling from certain height on another component, then the deformation of that component taking place in downward direction means the deformation is taking place in downward direction means that load has traveled this delta L amount of distance. That means H plus delta L, it represents the total displacement of that particular movable load, and to that total displacement, if I will multiply by the P, that is force, then I will get the work done. Therefore work done is equal to force into displacement, and by using this particular condition only we have derived this particular sigma formula. That big derivation we have discussed in the previous 2-3 lectures. So this formula, the second formula, is sometimes useful to find out this particular certain height. In this particular type number 3, sometimes we have to calculate the stress, that is maximum stress due to the impact load we have to calculate. Then deformation due to the impact load we have to calculate. In addition to that, sometimes we have to calculate the height of falling. Whatever your component is strikes from certain height, that height distance also we have to calculate. Therefore, this second formula is useful, that is strain energy is equal to work done. So you can take this particular formula in your notebook, that is instantaneous stress. It is also called as a maximum stress or stress induced due to the impact load. So take this particular formula in your notebook, that is sigma is equal to P upon A in square bracket 1 plus square root of 1 plus 2h upon delta L. Same formula I have written in the form of PL upon AE. Take the second formula also in your notebook for the solutions. Strain energy is equal to work done sigma square upon 2E into volume, which is equal to P in bracket H plus delta L. So based on this particular two formulas only, now we have to solve the numericals. Okay, so now we will start with the first numerical. So the first numerical is in front of you. How to identify whether problem is based on the suddenly, gradually, or the impact load. Already we have discussed the suddenly and gradually means the word suddenly applied load, the word gradually applied load, it is mentioned in the statement. But in order to identify the problem based on the impact load, either this falling height or the height is mentioned in that particular statement, then immediately we can say that that particular problem is based on the impact load. Now the statement is in front of you, so I will read the statement. So what that particular statement tells. So an object of 100 Newton, an object of 100 Newton weight is falling by gravity. An object of 100 Newton weight falling by gravity from a height 5 meters. So one object is there, it is falling from certain height due to the gravity, because whatever the load is falling, it is always in the downward direction, because self weight of that particular body, it is always in the downward direction. So the load is given, means movable load, 100 Newton load is given. Then its falling height, how much height is given? That is 5 meters. Full stop. When it is suddenly stopped by a collar, when it is suddenly stopped by a collar at the end of vertical rod. We have discussed about that particular figure. One vertical rod is there, that vertical rod is fixed at the top, and at the bottom side the collar is attached. So if that movable load is strike on that particular collar, the collar is moving in the downward direction, means deformation is taking place. Same construction is there, 100 Newton movable load is there, it is falling from certain height, that height is given 5 meters. If this load comes in the downward direction, and if it will be strikes on the collar, then the elongation of collar is taking place, and the length of that vertical rod, it is also mentioned, it is also given how much, 10 meter is the length of rod is given. Diameter of rod, it is also given 20 mm. Full stop. The top of the bar is rigidly fixed, already I have explained. Calculate the maximum stress and strain induced in the bar due to impact. So due to that 100 Newton load is falling from certain height, and if it strikes on the collar, how much amount of stress and strain induced in that particular collar or in that particular rod, because collar and rod both are rigidly connected to each other at the bottom side only. At the top, rod is totally fixed. Also find the strain energy stored in the bar. So whatever the load is falling on that particular collar, some amount of energy is stored in that particular collar or the rod. That strain energy also we have to calculate, and we have to take the constant parameter as a capital E is equal to 200 gigapascal. So first of all, we'll think about the given parameters, because here the given parameters are very important. So if we'll write, that is capital P is equal to how much it is given, 100 Newton. Capital P is equal to 100 Newton. Already the value is given in Newton, so need not require to go for the conversion. Then that weight is falling by the certain height, that height is given. How much amount of height is given? Capital small h is equal to 5 meter. 5 meter is equal to 5000 mm. Height is given. Then that load is suddenly stopped by the collar which is connected to the vertical rod. So length of that particular rod, it is given 10 meter is equal to 10 into 10 raised to 3 mm. So the length is also given 10 into 10 raised to 3. We have converted. Then diameter of rod, how much? 20 mm. Diameter of rod is given 20 mm. Then constant parameter capital E, it is given 200 gigapascal. So convert 200 into 10 raised to 3 Newton per mm square. And we have to calculate stress, we have to calculate strain, and we have to calculate the total strain energy stored in that particular rod. So these three parameters we have to calculate, and from this particular statement now we have easily understood that here the falling height is given, that is h, small h, falling height is given. Such types of the h factor, it will not be given in gradually applied load, it will not be given in the suddenly applied load, it will be given in only impact load. So we can say that this particular numerical is based on the impact loading condition. Also at the end also they have mentioned calculate the maximum stress and strain induced in the bar due to impact. Here I have written the stress and strain induced in the bar due to the impact. From this also we can say that this particular numerical is based on the impact loading condition. Now we have to calculate each and every parameters. So for the stress calculation we are having the formula. If I have to calculate the stress, then for the stress calculation I am having the formula. That is first parameter we have to calculate, that is stress in rod. Stress in rod. Okay, so now to calculate that particular stress value we are having the standard formula. If I will use that particular formula, that is, what is the formula? Sigma is equal to P upon A in bracket 1 plus square root of 1 plus 2h upon delta L. So this is the formula available to calculate the stress due to the impact load. So put all the values. Sigma is equal to P, it is given 100 Newton, we can take as it is. Area, to calculate the area of the rod we are having the diameter pi by 4 into d square in square bracket 1 plus again square root of 2 into h into AE divided by PL. Whatever the delta L term is there, that delta L is replaced in the form of PL upon AE. Now if I will solve, or if I will put all the unknown parameters here, so sigma is equal to this 100 Newton as it is divided by pi by 4, diameter is given 20 square in square bracket 1 plus again square root, sorry, so if I will write down the formula, sigma is equal to P upon A in square bracket 1 plus square root of 1 plus 2h upon delta L. This is the formula. Now put the value. This is the 100 divided by pi by 4, d square means 20 square, 1 plus square root of 1 plus 2 into height is given in meter, so it is converted in mm, that is 5000, into delta L means area, again here pi by 4 into 20 square into E 200 into 10 raised to 3 divided by P into L. Divided by P into L means 1000 into length 10 into 10 raised to 3. Because we are having the formula delta L is equal to PL upon AE, means 1 upon delta L is equal to AE upon PL. So now put all the values and find out the stress equation. So put all the values here, all the values are given, that is sigma is equal to, the P's we have kept, area is equal to pi by 4 d square, in square bracket 1 plus square root of 1 plus, this 1 plus in bracket square, whatever the 1 plus is given in the square root, it will be applicable for whole term. Please keep in mind this 2h upon delta L. For this particular 2h upon delta L, this 1 plus is applicable for the whole term. So try to solve this particular 2h upon delta L first. In that 2h upon delta L, add plus 1 and then take the square root. So now do the calculations and tell me the answer. What will be the stress induced in that particular rod due to the impact loading? How much amount of stress induced in that particular rod due to the impact loading? If you will calculate the cross-sectional area separately, pi by 420 square, you will get the area. Area is equal to pi by 4 into 20 square is equal to 314.15 mm square. Cross-sectional area is equal to 314.15 mm square, pi by 4 d square. So put all the values, cross-sectional area we have calculated separately. So put that particular value and find out the stress induced in the rod or stress induced in the collar. So how much amount of stress is induced?
252.63 Newton per mm square.
252.63, correct. 252.63 Newton per mm square. Okay, so due to this technical problem today, I am unable to write on that particular pad. So try to understand this. Do the calculations properly only. If you got the formula, put all the values. Yes, 252.63. This is the correct answer. Stress induced in the rod, or we can say that stress induced in the collar, because rod and the collar are rigidly connected to each other at the bottom side. So whatever the stress induced in the rod, same stress we can consider in the collar. Now the stress here, the calculation part is very important. So first of all, try to solve the square root, then add 1 in that particular square root term, and then you have to multiply by P upon A. While calculating the area or while putting the value of cross-sectional area, try to do the separate calculation for the area. Area is equal to pi by 4 d square, and then put that area value directly in the formula. If we can put the pi by 4 d square, then also no problem. But if we put the area value only, so your calculation part becomes very simple. So 252.63, this is the correct answer. Now stress we have calculated. Now we have to calculate the strain. How to calculate the strain? Strain induced in the rod. So strain induced in the rod, that is small e. So how to calculate the strain? Which formula I can use? How to calculate the strain? The stress I am having, strain I have to calculate. Which formula I can use? Yes, anybody? If I have to calculate the strain value from the stress, which formula I can use here as per the given data? So we are having the formula capital E is equal to Young's modulus is equal to linear stress upon linear strain. We are having the formula Young's modulus capital E is equal to linear stress upon linear strain. Why? Because whatever the load is movable, whatever the movable load is there, it is applied along the axis. It is applied along the axis, and due to that movable load, whatever the stress is induced, that stress is the linear stress, and whatever the strain induced, that strain will be the linear strain. So Young's modulus we are having how much? 200 into 10 raised to 3, which is equal to stress. Just now we have calculated 252.63 divided by small e. Now calculate the e is equal to, how to calculate 252.63 divided by 200 into 10 raised to 3. What will be the strain induced in that particular rod or the collar? How much amount of strain induced? Please do the calculation.
1.26 into 10 raised to 3.
Into 10 raised to 3 or 10 raised to minus 3?
minus 3.
Minus 3 is very
Minus
important. 1.26 into 10 raised to minus 3. This is the unit quantity. Because for the stress, unit is Newton per mm square. For the Young's modulus, again, unit is Newton per mm square. So Newton per mm square, it will be cancelled from numerator and the denominator. So whatever the strain you will get, it is the unitless quantity. So 1.26 into 10 raised to minus 3. 1.26 into 10 raised to minus 3. This much amount of strain induced in that particular rod or in that particular collar. So do the calculations properly. First of all, stress calculation, then stress calculation, then strain calculation, and then we have to go for the calculation of strain energy. So those who have finished, please do the calculation for the strain energy. Common formula is available for the strain energy calculation. First of all, do the calculation for the strain. Young's modulus is equal to linear stress upon linear strain. By rearranging the terms, I have written the formula in the form of small e, which is equal to stress upon Young's modulus E. Please do the calculations, others. Many of you are not doing the calculations. If you have solved, then find out the third parameter. What will be the third parameter we have to calculate? We have to calculate the strain energy. So strain energy, which is indicated by capital U. So the strain energy formula will be same for all the three types of loads. So it will be indicated by capital U is equal to sigma square upon 2E into volume, which is equal to sigma square upon 2E into area into length, because volume for the rod, it will be area into length. Now I have to calculate the U, which is equal to sigma. Just now we have calculated how much? 252.63 square, because sigma square is there, divided by 2 into 200 into 10 raised to 3 into volume. Volume is equal to area into length. So area pi by 4 into d square into length. How much amount of length is there? That is 10 into 10 raised to 3. And pi by 4 d square we have calculated 314.15. So you will get the strain energy stored in that particular body is how much amount of strain energy stored? You do the calculations properly. Sigma square, don't forget to take the square of the sigma. 252.63 square divided by 2E, 2 into 200 into 10 raised to 3 into volume. So yes, 501.25 or 24. 501.25 into 10 raised to 3 Newton mm. So this much amount of strain energy stored in that particular rod. So 501.25 into 10 raised to 3 Newton mm. This is the unit of the strain energy. So U is equal to sigma square upon 2E into volume. This formula, strain energy formula, will be same for the gradually applied load, suddenly applied load, and the impact load also. So in the previous, we have calculated the stress. Sigma is equal to, separate formula is available to calculate the stress due to the impact loading. Then by using that particular stress and the Young's modulus, we have calculated the strain induced in that particular rod or the collar. And by using the common formula of the strain energy, sigma square upon 2E into volume, we have calculated the total strain energy stored in the rod or in the collar. So 501.25 into 10 raised to 3 Newton mm. This much amount of strain is induced. Sorry, this much amount of strain energy stored in that particular rod. Please do the calculation. Those who have not done the calculation, please do the calculation. Only few students are doing it. Others, please try to solve this problem in your notebook and try to represent the answer in the chat box. Don't look at the things. If you are doing the practice of calculation, then it will become very easy during your examination. Try to do the calculations, because at the end I am going to check all the notebooks. Please keep in mind during submission. Just 501.24, 501.25 into 10 raised to 3 Newton mm. This unit is also very important. So try to write down the unit also. Okay, I hope everyone has done the calculations. So now we'll move to the next problem. So the next problem is in front of you. So which parameter we have to calculate? We have to read the statement first. A weight of 1.2 kilonewton is dropped on the collar. The word collar is mentioned, means immediately in the first line only we can say that this particular problem is based on the impact loading. So weight of 1.2 kilonewton is dropped on the collar attached at lower end. Same construction, whatever the figure we have used for the derivation purpose. One rod, vertical rod is there, fixed at the top side, and at the bottom side the collar is attached. And one movable load is there, which will be moved in upward direction and the downward direction on that particular vertical rod. So here the weight of 1.2 kilonewton is dropped on the collar attached to lower end, and the length of vertical rod is 5 meter. Length of vertical rod is given 5 meter, diameter 30 mm. Full stop. Calculate height of drop. Calculate height of drop if maximum instantaneous stress is not to exceed 120 megapascal. Calculate the height of drop if maximum instantaneous stress is not to exceed 120 megapascal. Full stop. Also calculate the elongation of rod, delta L, and we have to consider capital E is equal to 200 giganewton per meter square. So whatever 1.2 kilonewton load is there, if it is dropped on the collar, the elongation of the rod or elongation of collar is taking place. But whatever the certain height is there, that height is not mentioned in the statement. That 1.2 kilonewton load is dropped from the certain height. That height we have to calculate. And in the given, the length of rod, diameter of rod is given, and maximum instantaneous stress. That means due to that 1.2 kilonewton load, whatever the maximum stress is developed, that maximum stress is also given in the statement. In the previous numerical, we have calculated the stress induced in that particular rod. Now here, the stress induced in that particular rod is given, and we have to calculate the falling height. That height we have to calculate, and along with that we have to calculate the elongation of the rod due to this 1.2 kilonewton load. If it is strike on the collar, how much amount of elongation is taking place in the downward direction. So initially, first of all, we write down the given parameters, and then we'll think which formula we have to use. So in the given, P is equal to 1.2 kilonewton is equal to 1.2 into 10 raised to 3 Newton. Then length of rod L is equal to how much? 4 meter is equal to 4000 mm. Then diameter of rod 30 mm. maximum instantaneous stress means sigma is equal to sigma max. We can consider sigma is equal to sigma max is equal to 120 megapascal, means 1 megapascal is equal to 1 Newton per mm square. So 120 Newton per mm square. Then capital E is equal to 200 giganewton per meter square, which is equal to 200 into 10 raised to 3 Newton per mm square. And which parameter we have to calculate? We have to calculate height, or we have to calculate the elongation of the rod. We have to calculate the falling height and we have to calculate the elongation of that particular rod. Now please tell me which formula I can use, whether we are having any formula related to the height calculation, whether we are having any formula. We are having the stress formula and we are having the second formula, that is strain energy is equal to work done. So which formula we have to use for your further calculation? Yes, which formula we can use?
Strain energy equals to work done.
Yes, strain energy is equal to work done. That formula I can use for your further calculation, because if I will use the sigma formula, in the sigma formula that H is also present. In the sigma formula H is also present. From that also we can calculate the total height or the falling height. But we are having the very simple formula in the form of, that is in order to calculate the strain energy. So if height we have to calculate, which is indicated by small h, therefore we are having the strain energy. Strain energy is equal to work done. So strain energy formula we are having. What is the formula? Sigma square upon 2E into volume is equal to work done is equal to P in bracket H plus delta L. H plus delta L. Now I will write the same formula by changing some of the terms. Which terms I am going to change? Just see here. Sigma square as it is divided by 2 into E divided by volume for the circular cross section, area into length, which is equal to P as it is in bracket H plus delta L means PL upon AE. Delta L means PL upon AE, because here we are having the formula delta L is equal to PL upon AE. Okay, before that calculation, if I will calculate the area, pi by 4 into 30 square, what will be the cross sectional area? Pi by 4 30 square. What will be the cross sectional area? Please do the separate calculation. We can put the area directly in the formula. Yes, 706.85. 706.85 mm square. Okay, this will be the cross sectional area. Now put all the given parameters in the formula. So sigma square, sigma is given, maximum instantaneous stress 120 square divided by 2 into 200 into 10 raised to 3 into area 706.85 into length. How much amount of length is given? Length is given in meter. So we have converted in mm. 4000 is equal to P. It is given 1.2 kilonewton. So 1.2 into 10 raised to 3 Newton. In bracket H parameter we have to calculate. So H plus PL 1.2 into 10 raised to 3 into length 4000 divided by area, again 706.85 into E 200 into 10 raised to. So now do the calculation, simplify this particular terms. So try to take the unknown parameters at one side only. So if I will rearrange the terms here in this particular numerical, if I will write the formula in the form of H only. So this 120 square into 706.85 into 4000 divided by 2 into 200 into 10 raised to 3 into this 1.2, it is present at the right side. P 1.2, it is present at the right side. It is multiplied. If I will take this particular left side, so 1.2 into 10 raised to 3 is equal to, only term is remaining, H plus 1.2 10 raised to 3 into 4000 divided by 706.85 into 200 into 200 into 10 raised to 3. So at right side, H plus remaining term is there. At left side, total unknown parameters are there whose values are given. So try to do the simplification at the left side. Try to do the separate simplification or separate calculation at the left side. What will be the value? Please check your answer. What will be the answer? Do the separate calculation for each and every left side and the right side. Then at the end, whatever addition or subtractions are required, do it properly and find out the height. So at the right side, if I will go for the more simplification, this H plus whatever this H plus PL upon A term is present in the calculation. So through this particular simplification, I will get this 0.033 H plus PL upon AE. If I will do the calculation of PL upon AE, you will get H plus 0.033.
Yes, sir.
At the left side, this big calculation is there, numerator and the denominator.
84.82.
Yes. What will be the calculation for the left side? Yes, all of you are mentioning the height directly. So 84.87, 84.78. This is the correct, no problem. So the height, directly you have mentioned the height. So height is equal to, directly you have mentioned, height is equal to 84.82, 84.78 mm. All the answers are accepted. It depends upon the number of digits you are considering. So please do the calculations properly. Here calculation part is very, very important. Total strain energy is equal to work done. Strain energy, we are having the sigma square upon 2E into volume at the left side, and work done for the impact load, P in bracket H plus delta L. So if we put all the values, only unknown is remaining H. So please check your answers. 84.78, 84.82, 84.85, all the answers are accepted. The digits are changing due to the calculation. How much digits you are considering for the calculation, based on this, it will be considered. The height is calculated, then calculate the total elongation. We are having the elongation formula. Delta L is equal to sigma L upon E. Delta L is equal to sigma L upon E. put the value of sigma, put the value of length, and put the value of E. How much amount of deformation taking place? Please check. It's 84.78. This is the correct, no problem. Calculate the deformation or the elongation of rod. For the elongation calculation, the formula will remain same for all the three cases. Delta L is equal to sigma L.
2.4 mm.
Yes?
2.4
2.4
mm.
Yes, 2.4 mm. Here I have written the answer directly along with formula. Please check your answers in your notebook. Do the calculation. Simple formula. Yes, 2.4 mm. Simple formula. Delta L is equal to sigma L upon E. 2.4 mm. This much amount of elongation is taking place for the rod, or we can consider elongation is taking place for the collar also, because collar and the rod both are connected to each other. So how to solve this particular problems based on the impact load? Please focus on it. How to identify it? Whether falling height is given or that impact word, it will be also mentioned in the statement, or load is falling from certain height, like that statement is also mentioned. So from that immediately we can say that it is based on the third type, that is problem based on the impact loading condition. So only two formulas are there. By using the two formulas we can solve any type of numericals, and in this type number 3 only two varieties. Whatever the problem number 1 we have discussed, in which we have calculated the stress and the elongation, and whatever the problem just now we have discussed, in that the stress is given and we have to calculate the falling height. That means we have to calculate the H. So that means by using this two formulas only, sigma formula and strain energy is equal to work done formula, we can calculate the any type of the unknown parameters. Yes, I hope everyone has solved this particular problem. 2.4, this is the elongation taking place. Others, please do the calculations. Find out the falling height also, 84 point something mm, and then elongation of the rod 2.4 mm. So they rather than this two numericals, there is no any another variety based on this particular impact loading calculation. Either we have to calculate the stress, elongation and the strain energy by using the impact loading condition, or either we have to calculate the height or some elongation calculation. Stress calculation, strain energy calculation and the elongation calculation, same parameter we have to calculate for the gradually applied load, suddenly applied load and the impact load. Only conditions are different. Due to that conditions, only formulas are different for the sigma calculation. Sigma is equal to P upon A, sigma is equal to 2P upon A, and sigma is equal to P upon A in bracket, square bracket 1 plus square root of 1 plus 2H upon delta L. This formula should be at your tip of tongue, so we can solve any type of numerical based on the strain energy calculation. Okay, so this is the one problem. Now I will give one problem just for your solution, so try to solve it. So I will try to write down the statement in short, so through this we can solve this particular numerical. So I will read the statement. A unknown weight falling through height. The unknown weight falling through height. That means height is given. How much amount of height is given? Height is equal to 10 mm. The unknown weight is falling for the height from the 10 mm on the collar, which is rigidly attached to the lower end of the vertical bar of length. Length of bar is given. How much? 4 meter. Length of bar is given 4 meter, and the cross-sectional area, instead of giving the diameter, the cross-sectional area is directly given 600 mm square. Full stop. If the maximum instantaneous extension is known to be, if the maximum instantaneous extension means deformation is given, how much amount of deformation is taking place? 2 mm deformation is taking place. What will be the corresponding stress? What will be the corresponding stress developed? And value of unknown weight means we have to calculate the P also. And for this particular calculation, we have to take the E is equal to 200 gigapascal. So this is the statement for your solution. A unknown weight falling from the certain height. Weight is unknown. A unknown weight is falling from the certain height. Height is given 10 mm. It is falling on the collar which is attached at the lower end. And the length of that particular rod is given 4 meter. Cross-sectional area of that particular rod is directly given 600 mm square, and due to that unknown weight is falling on that particular collar, some elongation is taking place. That elongation is given 2 mm. Full stop. So due to that particular unknown weight, how much amount of stress induced and how much amount of stress induced, that two parameters we have to calculate. How much amount of stress induced and how much amount of unknown weight falling from certain height. These two parameters we have to calculate. Now do the calculation. Start your calculation. First of all, find out the stress and then find out the load and tell me the answer. Which formula I can use? Sigma is unknown. Which type of formula? Deformation formula. Because deformation is given. By using the deformation, just think which formula we can use. Deformation is given in the statement. So through this particular deformation, which parameters I can calculate immediately? Yes, 100. It is mentioned. 100. It is which parameter? Whether stress is there or load is there?
Stress.
Yes, stress. 100 Newton per mm square. Please check your answer. By using the deformation, we are having the direct formula. Delta L is equal to sigma L upon E. Because deformation is given in the statement. Use the deformation formula directly and then find out the unknown parameters. Yes, what will be the answer? Please check. Deformation is given 2 mm. Sigma we have to calculate. Length is given 4000. Divided by Young's modulus. How much? 200 into 10 raised to 3. What will be the stress? If I will use the big formula, sigma is equal to P upon A in square bracket. 1 plus square root of 1 plus 2h upon delta L. If I will use that particular big formula, then you will get the two unknowns. Sigma is also unknown and the force P upon A, this is also unknowns. So first of all, we have to calculate the stress. So for the stress calculation, deformation is given. Yes, 100 Newton per mm square. Please check your answer. 100 Newton per mm square. Then second, unknown weight which is falling on the collar. That unknown weight also we have to calculate. Now here for this particular unknown weight calculation, I can use the two formulas. Either I can use sigma is equal to P upon A in square bracket 1 plus square root of 1 plus 2h upon delta L. I can use this formula, or Or, but if I will use this particular stress formula, your calculation becomes lengthy. So instead of using this, if I will use strain energy is equal to work done. Strain energy is equal to work done. Therefore, sigma square upon 2E into volume is equal to P in bracket H plus delta L. So you can use both the formulas, but by using the first sigma formula, stress due to impact load, if I will use this particular formula, your calculation becomes very lengthy. If you want to try with this, we can go for that. But if you want the answer in the minimum number of steps, then you can use the second formula. Strain energy is equal to work done. So strain energy sigma square upon 2E into volume. Put the value of sigma. We have calculated 2E. Young's modulus is given. Volume, area into length already given is equal to P. It is unknown parameter. Height, it is also given. Delta L, 2 mm, it is also given. Within 2 to 3 steps, you will get the falling height. Sorry, falling load. That is P is equal to. Tell me the answer. What will be the unknown weight falling from the certain height? Its magnitude.
13.92 into 10 raised to 3 Newton per mm square.
How much?
13.92.
13.92. You check your answers. Try to do the square. Yes, try to do the square of sigma. Mean of you are forgetting the making the square of sigma. 5 kilonewton, this is the correct answer. Please check. 5 into 10 raised to 3 Newton or 5 kilonewton. 5 into 10 raised to 3 or 5 kilonewton. This is the unknown weight falling from the certain height. How you will get the 13 point something? Who has given that particular answer? Please check your answer. Maybe you are missing to convert the parameters in Newton, or you are missing to making the square of the sigma. Sigma square is given. If you are forgetting to taking the square of the sigma, 101% your answer will be wrong. So try to take the square of that particular sigma, try to convert all the parameters in mm, Newton per mm square. Young's modulus is given in gigapascal, so try to convert that particular E in Newton per mm square. Please check your answers. Calculation is very simple. So we can find out the unknown weight by using the sigma formula or by using the second formula also. Strain energy is equal to work done. But if you are trying with the sigma formula, sigma is equal to P upon A in bracket 1 plus square root of 1 plus 2H upon delta L. So through this particular formula also you will get the same answer. If you want to try, you can try at your home and check whether your answers are same or not. By putting the value of sigma, you will get only one unknown in the form of unknown weight. So try to solve this particular same problem by using the first formula or by using the second formula also, that is strain energy is equal to work done. And check your answers by using the both formulae whether you will get the P is equal to 5 into 10 raised to 3 Newton or 5 kilonewton. So this will be the homework. Again, the homework for you. Now we have solved the last point by using the strain energy is equal to work done. So now try to solve the same parameter by using the first formula. Sigma is equal to P upon A in bracket 1 plus square root of 1 plus 2H upon delta L, and compare your answer at the end whether you will get the 5 into 10 raised to 3 Newton or 5 kilonewton. Okay, have you understood this particular type? How to solve the numericals? Anybody is having any problem? How to solve the problems based on the problems on the impact load? How to identify the problem? Height is given, collar, rod, impact, like that words are mentioned in the statement. So easily you will get that this particular numerical is based on the impact loading conditions. Have you got this particular numericals? Only these three varieties are there. What is the problem? First numerical we have solved. In that the unknown weight is given. By using that particular unknown weight and the formula, we have calculated the stress and the elongation. Then second numerical we have solved. In that the stress is given and we have calculated the falling height. And whatever the third numerical is given to you for your solution, in that the unknown weight is given, remaining all parameters are given, deformation is also given. So by using that particular deformation, initially we have calculated the sigma, and then by using the two formulas, either sigma formula or either strain energy formula, we have calculated the unknown weight which is falling from the certain height. So these are the three variety of numericals based on the impact load. Rather than this, there is no any other variety based on this particular problems based on the impact loading conditions. So anybody is having any problem to understand this particular part, or anybody is having problem you have not understood? Yes.